In this video, we're going to look at why is mole important, especially in chemistry. And while we're at it, we'll start by looking at what's an Avogadro's number and how it's related to mole. So let's get into it. First of all, let's figure out what's a mole. Just to be clear, I'm not talking about the skin growth on human skin. Mole is a counting unit that we use to indicate the number that we're referring to. Take this socks for example. How many socks do you see? 2, right? And we don't say 2 socks. Usually we'll say a pair of socks. And what about this tray of eggs? Right, we see 12. And we don't call like 12 eggs. Usually we refer to them as a dozen. And just in case you're thinking like counting unit is associated with the object, that's not the case because a dozen can also be applied to something else like a dozen of muffin. So dozen, pair, these are just counting units that tells us the number that we're referring to. To be specific, 1 pair refers to 2. 1 dozen refers to 12. So what does 1 mole refer to? Well, it refers to 6.022140076 times 10 to the power of 23. That's a very, very large number. That's what 1 mole means. So now we know that mole is just a counting unit that's used to measure the amount of substance. After all, it's way easier to say 1 mole versus 6.022140076 times 10 to the power of 23. That's kind of long. That's why we just say 1 mole. Now, why is it that a lot of times in the calculation we see mole spelled with M-O-L without the E? Like, what's up with that? Well, that's actually the SI unit for mole. You know, like SI unit for mass is kilogram and for volume is meter cube. So for mole, M-O-L-E, the unit is MOL. That's pretty much it. So back to that large number of 6.022140076 times 10 to the power of 23, this number is linked to the Avogadro's constant or Avogadro's number. They are the same. They are abbreviated with N with a subscript of A. That's Avogadro's constant. It was named after an Italian scientist called Amedeo Avogadro in 1811. He first proposed that the volume of a gas at a given pressure and temperature is proportional to the number of atoms or molecules regardless of the gas. He's not the one that calculated this value, but he proposed this relationship. So you might be wondering, hold up, just now you just mentioned 1 mole is 6.022140076 times 10 to the power of 23. And now that's also Avogadro's constant? Yep. Think of mole as a conversion unit. 1 mole is equals to 6.022 times 10 to the power of 23. That means we can actually write it out in a conversion factor that looks something like this, where we can say it's 6.022 times 10 to the 23 of whatever that we're talking about. That's for 1 mole. So we can write it out in a conversion factor that looks like this. And that's going to allow us to easily use this conversion factor to convert from one thing to another. That's why Avogadro's constant is presented as 6.022140076 times 10 to the power of 23 inverse of mole as the unit. Since it's called a constant, that means this number is fixed. Just like a dozen always means 12 and a pair always means 2, so a mole always means 6.022140076 times 10 to the power of 23. Now, usually we kind of round it off to 6.022 times 10 to the 23, and that's accurate enough for our daily calculations. Now that we're clear about mole, the value 6.022 times 10 to the power of 23, and Avogadro's number, let's see how we can use mole and why it's important. Mole is like the universal conversion that allows us to go from one thing to another. For example, we can figure out how many atoms is present. 1 mole of aluminum atom is equals to 6.022 times 10 to the 23 of aluminum atoms. Now, instead of having Al, let's say we have CH4, so we can say 1 mole of CH4 is equivalent to 6.022 times 10 to the 23 CH4 molecules. Because aluminum only consists of 1 atom, so we just say aluminum atoms. But since CH4 is a molecule that consists of 5 atoms in total, we call it a molecule. That's why it's CH4 molecule. And similarly, if we have like ions, for example, Na+, so we can say like 1 mole of Na+ is 6.022 times 10 to the 23 of Na+ ions. So you get the idea. 1 mole of anything is equals to 6.022 times 10 to the power of 23 of anything. And just to be specific, atoms, molecules, ions, this we can just group them together and call them particles. So when you say like 1 mole of any particle is the same as 6.022 times 10 to the 23 of any particle. That means using Avogadro's constant, we can easily calculate back and forth between moles and particles. We can say 1 mole of aluminum is 6.022 times 10 to the 23 aluminum atoms. We can also go from CH4 molecules and then use that to calculate the mole of CH4. So we can go from moles to particles and particles back to mole, all just using the Avogadro's number. Aside from being able to convert between moles and particles using the Avogadro's constant, we can also interconvert mole with mass using the molar mass of that same substance. Similarly, if it's at standard temperature and pressure, which is STP, we can relate mole to volume of a gas using molar volume. And all these 3 conversions that we've just talked about, they are related to the same substance. Meaning, we can say like 1 mole of aluminum contains 6.022 times 10 to the 23 of aluminum atoms. So mole of aluminum, we get aluminum atoms. Or we can say like 1 mole of oxygen gas, like O2 gas, contains 32 grams of oxygen. So we're referring to the same thing, 1 mole of oxygen, mass of oxygen. Similarly, if we have like at STP, we have 1 mole of CH4 gas, that contains 22.4 liter of CH4 gas. So it's the same stuff, like 1 mole of CH4, we get volume of CH4. So all these 3 conversions are related to the same substance. And we can go back and forth between them. So now we can also connect mole of one substance to mole of another substance. And we do that using something called molar ratios, which we can easily get from the chemical formula or from the balance equation. So an example is like going from mole of carbon to mole of CO2. So notice carbon and CO2 are 2 different substances. That's why I write it out as like mole of A convert to mole of B, or vice versa. So basically, you can see from chemistry standpoint, mole is rather important because you can use it to interconvert between so many things. So if you're interested in seeing how we can do these conversions, do check out the next video that's coming out in this series. I'll place the link in the description box once it's available. Hey, thanks so much for spending the last few minutes with me. I really do appreciate it. If you found value in the video, definitely give it a thumbs up. Let me know what's your biggest takeaway. Feel free to share the video with anyone that needs this info. Subscribe for more chemistry videos like this, and I'll see you in the next one.